Designing learning outcomes and delivering lectures is only half the teaching loop. Assessing whether students actually learned the material is the other half. Writing clear, unambiguous quiz questions pitched at the correct cognitive level takes hours of concentrated effort. AI can generate those questions in seconds, but that speed introduces a serious risk: plausible-sounding factual errors that can mislead an entire class. To safely leverage this speed, you need a repeatable, structured pipeline. By standardizing how you instruct the AI and how you verify its output, you can cut the time required to build a course assessment from 3 hours down to 45 minutes. At the end of that 45 minutes, you will have a complete 10-question quiz. The questions will be fully verified for factual accuracy, intentionally balanced across different cognitive levels, and ready to distribute to your students. Before we begin, you need to gather 3 things: a clean, organized set of your lesson notes, explicitly defined learning outcomes, and access to a multi-tool AI setup. Specifically, we will be using DeepSeek and Claude. Relying on a single AI tool for all stages of assessment design creates a critical point of failure. Each model has distinct tendencies. By combining DeepSeek's strict adherence to structural constraints with Claude's superior capacity for nuanced reasoning, you create a system of checks and balances that makes accelerated quiz design safe. This diagram maps the 6 steps of the quiz generation pipeline. Step 1 gathers accurate source materials. Step 2 maps those to learning outcomes. Step 3 is the draft. For this, we use DeepSeek, which follows specific distribution constraints more accurately than other tools. To get a usable draft, you construct a 6-element prompt. You assign context, role, task, constraints, format, and examples. This framework constrains the AI to your teaching materials. You paste this instruction set, with your notes, directly into the DeepSeek interface. Within seconds, the tool generates a structured 10-question quiz. It assigns the requested Bloom's level to each item, writes the question stems, lists 4 options per question, and outputs an answer key with brief explanations. Never deploy this first draft directly to your students. While the formatting looks professional, the wrong answers the AI generates are often logically inconsistent or too obvious to test student knowledge. This initial output is merely a structural foundation. Until a human educator steps in to refine those distractors, the quiz has 0 diagnostic value. A multiple-choice question is useless if students can guess the correct answer simply by eliminating obviously incorrect options. Left to its own devices, an AI will often write distractors that are so noticeably wrong they fail to test any real knowledge. This graphic breaks down 3 distractor archetypes. The first is the common misconception, targeting specific, frequent misunderstandings. The second is the near miss, which is almost completely correct but contains a subtle error. The third is plausible wrong value, presenting a number reached via a procedural mistake. Looking closely at our DeepSeek draft, we find a distractor that is blatantly unrelated to the question stem. If a student avoids this option, it provides 0 insight into their actual understanding. This is where we switch tools. We copy this specific weak question and migrate it over to Claude, leveraging its superior ability to reason through nuance and context. We explicitly instruct Claude to analyze the question and generate a near-miss distractor to replace the useless option. Claude analyzes the correct answer and outputs a distractor that is highly plausible, fixing the weak point in the assessment. A multiple-choice assessment is only as strong as its wrong answers. The specific errors your students choose provide the exact metrics you need to identify where their understanding breaks down. Now you transition to critical auditor. This flowchart outlines the answer verification protocol. Step 1 requires you to check the facts against your source document. Step 2 checks the distractors for structural giveaways. Step 3 evaluates difficulty to confirm higher-order thinking. Step 4 is calibration. During this protocol, you will inevitably catch subtle hallucinations. Here, the AI answer key states an absolute definition, but a quick check reveals a direct contradiction with an exception in the original source text. Bypassing this review process leaves your assessment vulnerable to the specific errors the protocol is designed to catch. Without this mandatory verification, you risk distributing misinformation and compromising the deep trust your students place in the assessment. With the questions verified, you manually arrange the flow of the document. Place the easiest, foundational recall questions at the beginning to build student confidence before presenting the more demanding conceptual scenarios. Finally, conduct one last read-through of the entire document. Approach it as if you are a student encountering the test completely cold, checking for clarity in the instructions and consistency in the formatting. You now have a perfectly leveled, diagnostically rich, and fully verified assessment ready for the classroom. What used to be a 3-hour grind has been completed in under an hour. This process establishes the golden rule of integrating AI into your teaching workflow. The AI drafts, you calibrate. The machine handles the bulk generation, but you retain absolute authority over verification. Save this verified quiz document. In the next tutorial, it will become the foundational input we use to generate a comprehensive, highly accurate grading rubric. Modern pedagogical expertise is no longer measured by your ability to write a draft from scratch. It is measured by the rigor and judgment you apply when verifying the final product.